Penguin Audio presents Nano by Robin Cook, read by George Guidall. Preface. Smallness has been a most unappreciated attribute. We're always implored to think big and never small. But now, smallness sits at the convergence of chemistry, physics, and biology at a place called nanotechnology, which is transforming the world of scientific research and development, and which is going to have an enormous impact on medicine. Despite its emergence only at the end of the last century, nanotechnology is already a multi-billion-dollar phenomenon, with more commercial applications arriving on the scene at an ever-increasing pace. In the nanotechnology arena, small is very small indeed. The basic unit of length is the nanometer, 1/1,000,000th of a meter. Consider that if a marble were to represent a nanometer, then the entire Earth would represent a meter. A hydrogen atom is approximately 1/10th of a nanometer in diameter. A DNA molecule is 2 to 3 nanometers thick. Among living organisms, viruses range from 20 to 400 nanometers. Bacteria are larger. Salmonella, the cause of typhoid fever and 90% of cases of food poisoning worldwide, is on the order of 2,500 nanometers in length and about 500 nanometers in width, with a narrow tail-like flagellum also 500 nanometers long. The cells making up the human body are larger, with the disc-shaped red blood cell coming in at a diameter of around 7,000 nanometers, while white blood cells are 10,000 nanometers plus. This nano-netherworld is governed more by quantum mechanics than by the laws of macrochemistry and physics, such that bonds, forces, and fields prevail over mass, gravity, and inertia. And the power of these bonds, forces, and fields is stupendous, representing the potential energy locked away from the cataclysms of billions of celestial supernova explosions that have occurred over the lifespan of the universe. Within the microcosm of nano-sized constructs of individual atoms and molecules, surface phenomena assume particular importance because the ratio of surface area to volume increases dramatically, essentially exposing their negatively charged electron fields and thereby their characteristics. For example, in the nano realm, gold is not the color of gold, nor is it inert. More important for nanotechnology is the element carbon, the basic building block of life, already known to be versatile in forming both diamond and graphite. In the nanotechnology domain, carbon atoms have recently been found to form other astonishing and marvelous nano-sized structures when subjected to equivalent violent conditions that exist in the interior of red giant stars. These structures, called fullerenes, include 60 carbon atom buckyball spheres, 1 nanometer in diameter, and even more important for nanotechnology, nanotubes of varying length and structure 1.3 nanometers in diameter. These surprising constructs have unique physical characteristics, amazing strength, lightness, stability, and conductivity, and will assume increasing importance as nanotechnology surges ahead. In nanotechnology there exists a world of possibility, but also of potential threat. Not even the experts know of the environmental or health effects of nanoparticles. For example, it has been noted that concretions of carbon nanotubes, something they tend to do, resemble the microscopic structure of asbestos with its known carcinogenic tendency. The fact that nanoparticles penetrate the human body, even the brain, is a known fact. How damaging this could be is totally unknown. The second threat of nanotechnology is based on its immediate commercial success. In a very real sense, no one is guarding the multi-billion-dollar research and development henhouse. There is no oversight, like there had been with recombinant DNA research, on the potential negative impact of nanoparticles. Nanotechnology research is being done in thousands of private laboratories, each racing ahead willy-nilly to be the first to secure valuable patents in a competitive environment where secrecy is paramount, and the risks are minimized or ignored.
Sample complete. Ready to continue?